Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone and welcome back. We have officially finished the theory of chapter 1 and today we are going to solve past papers regarding to paper 2, only paper 2. Before we start, I need you to know a golden rule about Cambridge exam. Cambridge exam, they like to mix different topics. So sometimes we will find combined questions from chapter 1 and chapter 2. So we are not going to skip these questions of chapter 2. We are going to solve them. And later we are going to gain benefits from this. Okay, let's start. Bismillah. Question number 1. Bismillah, 1 second. Question number 1. What is the most accurate and precise method to measure the thickness of a coin? Use a micrometer screw gauge, while use a rule and look at the scale perpendicularly. Use a two-pan balance. Use the displacement method with motor in a measuring cylinder. Of course, I'm going to pick the first question, the first answer. Why I didn't choose it from the beginning? Because sometimes there is a trap and the examiner make a trap for us. So you need to read all the questions, not to choose the first one. Because the micrometer screw gauge is the most accurate, precise tools for measuring the thickness of a sheet of paper, even it is better than the vernier caliper. Using a ruler and look at perpendicular, this is an accurate technique, but the ruler can measure 2 millimeter and the thickness of a sheet of paper is 0.1 of the millimeter. So it will be very small and cannot be, we cannot use ruler for measuring it. Use a two-pan balance, it is used for measuring the mass, not for the thickness. Use a displacement method, it is used to measure the volume, not for the thickness. So the reason the correct answer will be letter A. The second question, a pendulum is swinging. 5 students each measure the time it takes to swing through 10 complete swings. 3 students measure the time as 17.2 seconds. Another student measure it as 16.9 seconds. And the 5th student measure it as 17.0 seconds. What is the average period of the pendulum? The period of the pendulum is the time taken by the pendulum to make one complete oscillation, the time of one complete oscillation. And they made I think 20 oscillations or what? A pendulum is swing. 5 students each measure the time it takes to swing through 10 complete oscillations. Sorry, not 20, 10 complete oscillations. Okay, 3 students got 17.2 and one 16.5 and one 17.0 out of the 5 students. To find the average time of the 10 oscillations equal, so we are going to multiply 3 times 17.2 plus 16.9 plus 17.0, all divided by 5 because we have 5 students. Let's do it here. So here is the fraction. I'm going to open the bracket. 3 times 17.2. I'm going to close the bracket plus 16.1 plus 17 over 5. It will give me 17.1 seconds. So the total time of the 10 oscillation, the average total time of 10 oscillations, 17.1. When I'm going to divide it by 10 to find the period T capital is the time of 10 oscillations divided by the number of oscillations. So 17.1 over 10, it's 1.71. So the correct answer is letter C, of course, seconds. Let's move to another question. A measuring cylinder containing only water is placed on an electric balance. A small, irregularly shaped stone is now completely immersed in the water. The diagram shows the equipment before and after the stone is immersed. If you looked here, we are going to see that we have a measuring cylinder, so it can be used for measuring the volume. Here is the reading of the volume before, and here is the reading after immersing the stone completely. So the reading V1 here V1 equals 40 centimeter cube, and V2 equals what? We have 6 and we have 70. So the difference between them is 10, and we are in the middle, so it's 65. So 65 centimeter cube. To find the volume of the stone, V of the stone will be V2 minus V1. 65 minus 40 equal to 25 centimeter cube. So the volume of the stone is 25 centimeter cube. And here the reading of the balance, the reading of the difference of the reading, and we can estimate the mass of the stone, because the only change is the stone in the second reading. So the difference between them will give us the mass of the stone. So the mass of the stone, M in any place, M of the stone M of the stone equal 2.217.5 minus 10,105.0. The difference between them, so 217.5 minus 10,5.0 equals 112, 112.5, 112.5 grams. And it's asking what is the density of the material of the stone. Density equal what? Density equal mass over volume. And we have the mass 112.5 and we have the volume 25. So I'm going to substitute here. So the answer divided by 25 equal 4.5. So the answer 4.5 gram per centimeter cube. Don't forget the units. And if you looked here, the value is 4.5 within two significant figures, one decimal place, and it's accurate value. Okay. Question number 4. The masses of a measuring cylinder before and after pouring some liquid into it are shown in the diagram. The mass is 80 grams, and after adding the liquid, it becomes 180. What is the density of the liquid? Density of the liquid, again, it is the mass of the liquid over the volume of the liquid. What is the mass? The difference between them, 180 minus 80 will give us 100. So the mass is 100 grams. What is the volume? It was 0, and after adding it, we have 100 and we have 200. How many divisions are between 1, 2, 3, 4, 5? 5 divisions. So 100 divided by 5 will give us 20. Because 20, so each division is 20. So the volume is 140, 140, because we have two divisions. So here is 140 centimeter cube. Here is the unit. So over 140. 100 over 140 will give us, or we can see it here, 100 over 140 with no need for finding the result. It's 100 over 140. Let's move to another question. A steel ball bearing had a mass of 24 grams. So the mass is 24 grams and a density of 8.0 grams. So here is the density. It is lowered into a measuring cylinder containing 12 centimeter cube. So here is V1 of the water. What is the new water level? So it's asking about V2 in the cylinder. So we need to find the volume. The volume, density equal mass over volume, density equal mass over volume, rearranging the equation, making the volume the subject. So the volume equals mass over density. So the total volume is mass over density. What is the mass? The mass is 24. What is the density? Is 8.0. So 24 over 8 equal 3. So 3.0, here is the total volume. And the V, the volume of, is equal to V2 minus V1. So if V is 3 and V2 is unknown, so V1 is 12. So I'm going to move V1 to the other side. It will be in positive. So V2 is equal 15. So the answer will be 15 centimeter cube. So this is question number 5. Regarding to question number 6, students measure the volume of a rock. He puts some water into a measuring cylinder, and then one glass bowl, he puts the cork, and then a second identical glass bowl into the water as shown. So here is the volume of the liquid in the beginning. We have 20, we have 40. So here we have 30, here we have 10, here we have 50. So the volume of the liquid, V of the liquid equal 50 cubic centimeter, because here is the scale, 50 cubic centimeter. And here we have the volume with the volume of the glass bowl is the difference between them. So the volume of the bowl equal 10 centimeter cube. Now we are asked for finding the volume of the cork. So here we have the volume of the cork, piece of cork, because it's a floating object. So we added the glass bowl to force it to be totally immersed under the water, and the total volume is 100. And we have uh, two pieces of glass balls, or two glass balls, which is 20 for the glass bowl, 20 cubic centimeter, and the water is 50, so the total is 70, and the 70 from 100 is 30. So what is the volume of the cork? The volume of the cork will be 30 cubic centimeter. Okay يا أولاد؟ Let's go to question number 7. A student investigates the rate of flow of oil through a funnel. The diagrams show the experiment and the volume of the oil in the measuring cylinder at the start of the experiment and 1 minute later. What is the rate of flow of oil through the funnel during the 1 minute? We are going to find the rate of flow during the 1 minute, and then we are going to choose the correct answer, and you will observe that the rate of flow here is per second, not per minute. So we need the result divided by 60 in order to find the choice, the correct one. First of all, we need to find the reading in the beginning and the reading at the end. The reading in the beginning, we have 20 and we have 40. The difference is 20. And how many divisions do we have? 10. 20 over 10 will give us 2. So each small division is 10. So the reading here is 22. And here is 60, 62, 64, 66, 68, 70. So here is 70. 70 cubic centimeter. The difference between them will give us the rate of flow during the whole minute. So 70 minus 22 equals what? 70 minus 22 equal 48. So 48. It's not the correct answer. 48, don't go to 48 because the rate here per second. So 48 divided by 60 will give us the rate of flow. So 48 divided by 60. So it's 0.80. So 0.80 centimeter cube per second. So B is the correct answer. Question number 8. A measuring cylinder contains some water. A small metal block is slowly lowered into the water and is then removed. Finally, a piece of plastic is attached to the metal block, and the block is again slowly lowered into the water. The diagrams show the measuring cylinder at each stage of this process. What is the volume of the piece of plastic? The piece of plastic make the change only between 2 and 3. No need for finding the measuring of the metal block. If we are going to take the reading here is 70, the reading here is 80. The difference between them is due to the piece of plastic. So 80 minus 70 is 10. So the correct answer is letter A. Question number 9. A length of cotton is measured between 2 points on a ruler. So what is the volume here? Is 2.4 centimeter. And what is the length at the end? 15.6. 15.6. The difference centimeter also. The difference between them is the length of the cotton. So 15.6 minus 2.4. 15.6 minus 2.4 equal 13.2. 13.2, the total length of the cotton. When the length of the cotton is wound closely around the pin, it goes around 6 times. What is the distance once around the pin? So 13.2 divided by 6. Divided by 6 will give us 2.2. So 2.2 centimeter is the correct answer. Let's go to question number 10. An oil tank has a base of area 2.5 meter square and is filled with oil to depths of 1.2 meter. We have the area, we have the height or the length, the density of the oil, we have the density. What is the force exerted on the base of the tank due to the oil? You know, force equal mass times the free fall acceleration. We need to find the mass. Density actually equal mass over volume. So mass equal density times volume. Do we have the density? Yes, the density is 800. What is the volume? Area times height. So 2.5 times 1.2 will give us the mass. And then we are going to multiply it by 10. Will give us the weight or the force exerted on the base of the tank due to the oil. Let's find it. 800 times 2.5 times 1.2 equal 2.4 times 10 to the power of 3. And then we are going to multiply it by 10 for the free fall acceleration, 2, 4, and then 3, 0, 24,000 newtons. So the correct answer is, so 10 questions, I think, are enough. And later we are going to solve questions. And as I said, the questions are always mixed together. So a question from chapter 1 and chapter 2 are mixed together. When we are going to practice on chapter 2, we will see questions regarding to the measurements and the unit and the significant figure, the addition of vectors and so on. Next time, inshallah, I'm going to solve paper 4. Good luck and see you again. Assalamu alaikum wa rahmatullahi wa barakatuh.